Thank you for having this opportunity to present our infrastructure here. We have with Esa Turunen a combined presentation. I have the first part, and then when I end, Esa is continuing. Thanks. So our place in Sodankylä, about 100 kilometers east from here, is called Tähtelä, home of stars. And we call it Sodankylä Science Super Site. There is about 70 people, mostly high educated people, working in the area. Some of these are operational, some are highly scientific people. So the area is around 1 kilometer on River Kittilä or on the side of River Kittilä, and all the buildings are there in heavy use. If you are interested, you can find something like 10 saunas on the area. So I come from Finnish Meteorological Institute and Arctic Research Unit, which operates both in Sodankylä and in Helsinki. We have one group especially concentrating on climate change and studies of climate change, and they mainly work in Helsinki, but the whole unit is about 50-55 employees and 30 people in Sodankylä. So then we have a satellite center there, and also technical services, and also satellite services and development technologies there. So first we are measuring different things in atmosphere, and there are some nice pictures of bigger balloons we launch every now and then. Also we use aircrafts. This is a Russian special stratospheric aircraft, possible to fly up to 25 kilometers high. That's very unique. We are very international, and most of our facilities are part of international network. This is one of these global atmospheric watch network, like you see worldwide operations. And one is called Pallas Sodankylä. So Sodankylä is 100 kilometers east, and from here, and Pallas about 100 or less than 100 kilometers west from here. So double place for there. So we have activities both in Sodankylä and in Pallas. And Pallas is a very clean air place, maybe the cleanest air in Europe, plus also Alp areas are the clean places because they are so high places. So we measure practically the pollution which totally is transported from anywhere else to Pallas, and that's a very ideal place for that because there is no production of any pollution near Pallas. But then we also measure in long-term data records various things in Sodankylä, and which have been measured over almost 100 years in same place. We use also the data collected for the analysis of the coming new data. Then because the climate change is very important thing, we also are part of so-called GRUA network, which is upper air measurement network. Like you see, Sodankylä again is the northernmost place in the global network. So the key point is the total carbon column, and for that we have unique instrumentation in Sodankylä. Like you see in the list, carbon dioxide, which is the key point, this is one of these. Then methane comes maybe in the future more important, and other species. These all are our targets to monitor in Sodankylä. So here is a short list of all the observations. Actually, we operate all the time around 300 different instruments in Sodankylä, and that's a huge work to maintain it technically, so they are operational instruments all. So there is atmospheric observations, but then also soil and snow observations on the ground. One thing which is for both of us, I mean Geophysical Observatory and the FMI Arctic Research Unit in Sodankylä, is long-term measurements. Like here you can see temperature records over 100 years in Sodankylä. And one key point is, since 1980s, the turn up of temperature. This is the yearly average temperature in Sodankylä. So about 1 degree, but the key point is that the yearly average temperature is over 0, so plus temperatures now. And that's turning to be critical on Arctic areas. But at the same time, the upper air in the stratosphere is cooling slightly, which you see on the right-hand picture. So the ground temperature is increasing, but the upper air is decreasing, temperature is increasing, and that's the reason, because the warming is on the ground in the greenhouse, and then there is no transfer back to the space from the ground, or less transfer. Okay, I turn to the terrestrial measurements. So this means local measurements on the ground, mainly concentrated on snow, but also forest measurements or biology in the forest and things like that. Most of the things are satellite calibration and validation. Satellites represent the measurements global meaning. I mean, the whole world is covered with satellites very easily, but from the ground we can have very accurate local measurements. And the target is to get the satellite data in a better quality for operational use. This is called calibration and validation. One example was for a proposal for European Space Agency, a satellite core HO2, which unfortunately never realized. There was a competition of 3 coming satellites, and this was not chosen for the future. But we tested all the methods of the satellite instruments on the ground and on the mast in Sodankylä to be sure what the satellite could be measuring. But part of the measurements is in situ, which means in the winter time hard work digging in the snow, like you see in the parameters, different species or different things of the snow are measured on daily basis, on the lakes, on the swamp area, on the forest area. More than 20 people of our staff is on daily basis in winter time on the tracks there measuring the snow. Continuing with snow measurements, again one good example of international relations. WMO is the United Nations top organization for all the meteorological organizations, and we have a network of testing coming snow measurement instruments, and Sodankylä is one of the sites in the world, and again the northernmost of them. We have a nice satellite antenna in Sodankylä, and this needs about 80 meter in diameter round empty place in the forest to get a good horizon for the satellite, or for the satellite antenna. And we have used that for test field for the snow measurements. So all the points there on the right hand picture are equipped with the internet and electricity. It's very easy to put all kind of snow measurement instruments on the field in very good environment condition. This is one of these precipitation gauge is inside of this wooden fence system. The aim is to protect the instrument of any kind of wind effect. First of all, the forest field is first stage of the protection, then this wooden double fence is a second stage, and then there is even metallic fence close to the instrument. This is a reference which eliminates all the wind effects of the precipitation inside the gauge. This is the next step. There is a standard gauge, the white box there, and metallic wind fence around. So the idea is to automatically measure snowfall. There is a hole in this gauge, and the snowfall is melted and then measured, and we get automatically the yearly or the winter season snowfall from this instrument. Our satellite data center is more or less ready and operational now. Maybe we can change the text there, under development to developed, and to national data center. That is even in the Finnish space strategy mentioned, and maybe developed even further in the future. But we have two satellite receiving antennas, one 10 years old and one quite new, 2 years old, bigger one. Then we have a operation room, and we have also the computer room for the operations. The first one was 2.4 meter so-called direct broadcast antenna, which needs the direct access to the satellite when it's flying over Sodankylä. But the second one has bigger capacity and is able to receive data from almost any kind of nowadays environmental satellites or coming satellites like European Space Agency and European Union CMES and system. The satellites are called Sentinels, and Sentinel-1 is one, maybe the first which we can receive. Then we also receive, now we have contract with Italian company, with Cosmo SkyMed, which is a very high resolution satellite. This is operation on demand, and the customers pay of the operation we do. It's nice to have the last presentation or the previous presentation of icebreakers. We serve the icebreakers. In FMI we have a ice service unit which use our satellite data. This is a picture of Gulf of Bothnia, which has the Swedish side and the Finnish side. All the harbors are year-round open, and certainly there is a need for icebreakers and icebreaker services. This is a nice picture of Gulf of Finland. The lower part is the Estonian side, and the Helsinki is on the northern part of the Gulf. In very hard southern wind condition, all the ice was pressed towards Finnish side. That was even so thick that one icebreaker was stacked in the ice at that time. It's a couple of winters ago. So this is a nice satellite picture of open area on the Estonian side and very thick ice on the Finnish side. So, as my conclusion, this is not all we have in Sodankylä, but some short examples of all the measurement things. But it's a large facility with a huge instrumentation. It's even the northern location, it's easy to reach the location. We have roads open, we have flight connections to northern Finland and so on. Then we even have guest rooms for visitors, because most of our things are, so our visitors make own measurements on our field. They need also the guest rooms to be accommodated on the place. Then observatory type of work has long experience, especially hosting this campaign-based work. And then we have experienced staff for this kind of work. We can assist the visitors as well on their instrumentation. So, long and stable operation in Sodankylä, which has a good prospect for the future, and we are still expanding in Sodankylä. I think next is the last slide. This is the antenna and nice aurora there over there. Now I give the floor for Esa and...
Just one question.
Yeah,
between.
please.
Thank you. And as you remember, Japanese couples come here because they want to make love during the aurora borealis, and they believe that it's a boy, then the baby. But I have to ask you, Mr. Aulamo, that once more, the situation of the climate change in your perspective. I just read the other day that the ice melting has slowed down now during the last year in North Pole area. But you still say that the stratosphere is cooling, but still the ground temperatures are rising in the long distance perspective.
Yes, the ground temperature is more critical for the climate change, because this is really this greenhouse effect, because the greenhouse effect gives the warm air on the ground, and then the upwards transfer of the heat, sun heat from the ground back is less, and that's why it's cooling on the higher atmosphere. But concerning this climate change, the temperature change and critical over zero is now, which is realized. And I've also mentioned the methane. Maybe in the future, if the permafrost is melting,
yes,
this produces huge of methane in the air, which is even more critical than CO2.
Especially in Siberia.
Yes, and Arctic areas in general. So we are measuring on the Arctic area, but we can also go east and west on the Arctic area and see the same phenomenon.
Some questions here? Of course, we can discuss later after Mr. Turunen has given his representation. Thank you, Osmo